All right, we're going to talk about adding and subtracting polynomials. If you remember, polynomials were just things that were multiple terms or even one term, but expressions essentially. So this first polynomial has three terms in it. So this first one is a trinomial, if you remember that. This one has 1, 2, 3, 4 pieces in it. So this is 4 terms. This has 4 terms. Still a polynomial, just so happens that it has 4 terms. You don't have to have the same number of terms in order to add these two polynomials, because all you're really doing is getting rid of parentheses and then combining like terms. So in order to get rid of these parentheses, there's nothing on the outside here other than a 1. And so if I multiply everything by 1, I can just rewrite this without doing anything special. So to get rid of these parentheses in the first polynomial, all I have to do is rewrite it. Almost like in your mind after that, separate that from this other one. There's a positive and there's nothing written, so that means that the implication is that there's a 1, just like there's an implication of a 1 there. I'm going to distribute this positive 1 to get rid of these parentheses. Again, if I just multiply everything by 1, I don't change it. So in order to get rid of these parentheses, I don't have to do anything fancy here either. I have a positive 4y squared, this one, minus 4y plus 2y cubed plus 8. So in essence, when I decided to add two polynomials, I didn't have to do any kind of real distribution because my number out here was a 1. If this happened to be a 3, I would have to distribute the 3 first because I can't do the parentheses. I can't really combine these two until I get rid of the parentheses. But as it stands, this is what I have. I do have a y term here. Let me scope through. Oop, there's a y term there. And that's it. I have 3y minus 4y. That's negative y. If it helps, cross those out. Now let's talk about the y cubed. There's a y cubed. Oh, there's a y cubed. I have 1y cubed here. I have 2y cubes here. That's plus 3y cubed. Let me get rid of those now. I do have a number, but I like to do numbers last. Let's do this y squared piece. Oh, that's the only one. So it's a positive 4y squared. Let's get rid of that one. And then I have a negative 5 plus 8, which will give you a positive 3. This is done. Now you might see that people want it done or put in standard form. All that means is the highest exponent comes first and then go down in order. So this piece would go first because of the 3, then it's squared, so that one, and then it's y, and then it's that one. So I would just write it again as long as my signs are right. So 3y cubed plus 4y squared minus y plus 3. Both of these are equivalent, but sometimes, or most of the time, you'll see it in standard form, or they'll want it in standard form. Let me do an example of one where we're subtracting. Let's try, find a good one here. Okay, what about, in parentheses, 3 minus 2x plus 2x squared, and I'm going to subtract from that 4x minus 5 plus 3x squared. I'm going to pick this up a little bit. Now to get rid of these parentheses, there's nothing out here I need to do fancy, so it's just a 3 minus 2x plus 2x squared. Now I kind of like to look at that separately. Now I need to distribute a negative 1 though. So negative 1 times 4 is a negative 4x. A negative 1 times a negative 5 is a positive 5. And then a negative 1 times a positive 3x squared is a negative 3x squared. So I had to distribute that negative first. Now I can just combine like terms. Let's go with the x squared terms first so we can put it in standard form. That had to be negative x squared because that's a positive 2 minus 3. Let me cross those out. Now let's look at the x's. There is a negative 2 and a negative 4. Altogether, that's a negative 6. Get rid of those two. And then we have a positive 3 and a positive 5, which is a positive 8. It is in standard form already because I started with the highest term. That's how you subtract polynomials.